Hi guys, today we'll be learning about Diffie-Hellman problem in cryptography with the subject code 18CS744. The problem they have given us here is we are having a common prime which is q is equal to 11 and we are having alpha, the primitive root, to be 2. Okay, now what they have asked us here is three questions they have asked. Show 2 is the primitive root of alpha, and if user has ya is equal to 9, what is its a's private key xa? If the user has yb is equal to 3, what is the secret key k shared with a? Okay, we have to find out that. So the first question, it's very simple and very basic. What they have asked is show 2 is the primitive root of a. Okay, so for the primitive root, always keep this in your mind, alpha should be less than q. Okay, this is a point which in Diffie-Hellman we say alpha is always less than q. Okay, so keeping this in mind, we have to check whether how it is primitive root. Okay, to find it is primitive root of q, we have a formula saying that alpha to the power x modulus of q. Okay, we have to find and go. Now, what is this x? X is nothing but it is from 1 to q minus 1. Okay, so till there we have to evaluate and go, and we will get one set at the last from 1 till q minus 1. This set we have to get. Okay, then we can say that alpha is the primitive root of q. Now what is alpha? Alpha is 2. 2 power 1 modulus of q is nothing but 11. Okay, so we will calculate the modulus. 2 power 1, obviously 2 is less than 11, so it will be 2 only, correct? Then 2 power 2 modulus of 11, correct? What is 2 power 2? 2 power 2 is nothing but 2 modulus of 11. 2 power 2 is 4. 4 modulo 11 is 4. 2 power 3 modulus of 11, which is 8. 8 11 is again 8. 2 power 4 modulus of 11 is equal to 2 to the power 4 is, we will check, 2 power 4 is nothing but 16 modulus of 11. When you are calculating, you have to divide the 16 by 11. You get 1, minus it with 1, you get a value into 11, you are getting 5, correct? Then 2 power 5 modulo of 11 is nothing but 2 power 5 we are calculating, divided by 11 minus 2 into 11, we are getting another, we are getting 10 here, and then 2 power 6 modulo of 11, two power 6 is nothing but 64, divided by 11, what you are getting is minus 5 into 11, we are getting 9. 2 power 7 modulus of 11, we will get the value, we will check out with the value what we get for this, minus 11 into 11, we are getting 7. 2 power 8 modulus of 11, 2 power 8 divided by 11, you are getting a value 23, minus 23 into 11, we will get 3. Then next, let me write it here, 2 power 8 over 2 power 9 modulus of 11. Okay, another two more values, 2 power 9 and 2 power 10 modulus of 11. Okay, 2 power 9 when it comes, 2 power 9 divided by 11 minus 46 into 11, we get 6. And then we come here is 2 power 10 divided by 11 minus 93 into 11, we get 1, correct? Now, okay, now what we will include. Now we are having 1, you're having 2, you're having 3, you're having 4, you're having 5, you're having 6, you're having 7, you're having 8, then you're having 9, then you're having 10, right? So 1 to 10, you're having. Therefore, what we can say, 2 is the primitive root of 11. Okay, so we got 2 is the primitive root. Now we'll move on with the second question. Second question says that we have to find xa. Okay, the private key of a, given that yb is equal to ya is equal to 9. What they say, ya is equal to alpha to the power xa mod of q. Okay, this is your value. Now what we have to say, we can assume any number. Always remember that xa is less than q, so it should be less than 11. Okay, so let us assume a number so that we can take this. Assuming xa to be 3. Okay, let's see what we get, right? Do we get 9 or do we get any other number? Okay, now xa to be 3, right? So yb is equal to 2 to the power 3 modulus of 11, right? So 2 to the power 3 is what? 2 power 3, which is 8 divided by 11 minus 0 into 11. What we are getting? We are getting 8 only, right? So our assumption of xa, which is giving 8, but ya, what they have given, is equal to 9. So our assumption of xa equal to 3 is wrong. So let us assume xa to be 4. Okay, so what is this ya? You get 2 power 4 modulus of 11, right? Correct. So what is this 2 power 4? 2 power 4 is 16, correct? 16 divided by 11, you get a value minus 1 into 11. What did you get? You get 5. So again xa is equal to 4 is wrong, correct? So what is that value we have to get? So let me tell you one thing, how to identify it. See, we have already done here the same problem, right? To say that 2 is the primitive root of the primitive root of 11. So here you got a 9 here to value number 6. So your assumption, you can take an assumption. Let us assume xa is equal to 6. Same way how you did for primitive root finding, you have to do for this also, so that you get 9. So ya is equal to alpha to the power 6 modulus of 2 to the power 6 modulus of 11, which is nothing but your 9. So ya is 9. What they have given also ya is equal to 9. Hence what can we say? Hence we can say that our assumption of xa is equal to 6 is true. Therefore xa is equal to 6. Did we get our second point? Done. Enough. Third question. Let us answer for the third question. What is the third question? Third question says that I have been given yb is equal to 3, and what is the secret key k? I have to find k which is shared, that is yb only. Yb's k I have to find. Okay, to calculate k we have a formula. K is equal to yb to the power xa modulus of q, correct? So we know what is xa, right? We calculated here xa is equal to 6. What is yb? 3 to the power 6 modulus of 11. What will we get? 3 to the power 6 modulus of 11. Let us see. 3 power 6 divided by 11, you get 66 minus 66 into 11. What did you get? You got 3. So the key share is also 3. Okay, So this is how you can calculate your modulo function, your Diffie-Hellman key problem. Okay, so be careful when you calculate this and this xa also. Okay, based on that you can simplify your answer. Here let me clarify you one thing. Okay, for the user a, basically what it says is k is given by y a yb. Here it will become reverse, yb xa modulus of q. And for user b, it is given, k is given by ya to the power xb modulo of q. Okay, now it in the Diffie-Hellman, there it says both the keys will give identical results. Okay, keeping this in your mind, you can calculate it by this way also. Otherwise, if you want to make it even more, like you want exactly using this formulas only, you can again calculate y. They have given us yb is equal to 3, so which implies that where we have got 3, here we have got 3 to the power 8, so which says that if you take xb is equal to 8, then you will get that value 3. Okay, therefore if you substitute this in the formula where ya is given to be as 9, okay, ya you are substituting in case formula, k is equal to 9 to the power 8 modulo of 11, you get k as 2.9, which is almost equal to 3. We can't take decimal numbers, we have to take a whole number, which is 3. So your key answer is 3. You will get the same answer, identical results, if you do it in any ways. Okay, this is all about your Diffie-Hellman key problem.